Okay, so the last section of Chapter 7 is chemical methods of control, and to some degree, there's some things I want to talk about here, and then the rest of it I think I want to wrap up fairly quickly. So, chemical methods include halogens, alcohols, surfactants, preservatives, etc. There are some others: phenolics, quaternary amines, ethylene oxide. These are all chemicals. They cause microbes to die in various different ways. Let's look at it. But before we do, here I want you guys to understand this thing called the disk diffusion method. Hopefully that you can see that a little better now. Disk diffusion method used on a bacterial lawn is a useful measure of effectiveness of disinfectants. So, what you have here is three auger plates. There's 1, 2, and 3, and on each of these auger plates there's been put various kinds of bacteria: Staph aureus, gram-positive; E. coli, gram-negative, and another gram-negative, Pseudomonas aeruginosa. And these three different bacteria have been smeared all the way across, so you can see this sort of up and down smear lines of what's called a lawn put on these plates. Up and down each of these was streaked with a bacterial culture, and that culture was intended to make wall-to-wall bacteria. On that lawn was placed some discs. These are little paper discs. You might make these with a hole punch. And you take out the little paper disc from a hole punch, and you have a little disc that looks like a two-dimensional circle, but it's still a three-dimensional piece of paper. And it may be thin, but it's a three-dimensional thing, and it's made out of paper, and paper can absorb stuff. Well, you can soak your disc into a chemical, a disinfectant chemical of known concentration: chlorine, orthophenylphenol, hexachlorophene, quats, or whatever. And then you have a known amount of that disinfectant on that disc. You put that disc onto the auger plate and see what happens. Well, which of the chemicals was most effective in controlling the growth of E. coli? Well, if we look at E. coli, we can see there's no bacteria growing around chlorine, so this chlorine-based chemical is most effective, whereas orthophenylphenol was kind of effective, quaternary amines somewhat less effective, and hexachlorophene was completely ineffective as a control agent for E. coli. Likewise, many of these chemicals were completely useless against Pseudomonas. And again, so I guess the take-home message here is different kinds of chemicals kill different bacteria with different levels of lethality, I suppose is the term. Okay, so that is the disk diffusion method, and we'll also see that that disk diffusion method is used in the measurement of the effectiveness of antibiotics. So, which treatment is more effective? Well, we can see that this one, which did not get a lawn, it was, I don't know where this sample came from, but if you have a 10-to-1 diluted sample, it's completely ineffective, whereas an undiluted sample of is completely effective. So, so how much you dilute your chemical, well, there's a critical point at which if you dilute it too much, it's completely ineffective for anything. So, and that has happened somewhere in between full strength and 10-to-1 dilution. So, orthophenylphenol and phenol, these are chemicals. These are nasty chemicals that disrupt plasma membranes. Phenol is not often used, but phenolics that are less toxic are. Let's see. Triclosan is a bisphenol, And bisphenols, you can see, are two benzene groups or phenols because they have an alcohol hydroxy group on them. So this is triclosan, and triclosan is used in many antibacterial products. When you use antibacterial soaps, those often have triclosan in them. And there's some concerns about whether those are good for you or not. Biguanides, these are chemicals that are lethal. Chlorhexidine is a kind of a biguanide. I think, yeah. So these are in a lot of medical scrub soaps. Halogens, iodine, chlorine, these are all halogens. Yeah, so and those are kill a lot of microbes. Iodophores are when we take iodine and covalently bond it or make a complex with an organic substrate that makes it last longer and makes it evaporate less. Alcohol, there's a critical concentration that is effective. You go below or above that concentration, it doesn't work so well. Surfactants basically are soaps, and their purpose is primarily to make bacteria let go of your hands, basically. Get them to wash down the drain, not to kill them. So that includes soaps, and things like quaternary amines are surfactants. These ones, quaternary amine is a surfactant that is also bactericidal, and so that's often used in food service industries. Yeah, so that's quaternary amines, and there's a big bottle of them. Here's the chemical formula. There's the amine with 1, 2, 3, 4 covalent bonds and a positive charge. That's called a quaternary amine structure. And let's see. We also saw that in the TMAO assignment. There was a quaternary amine in TMAO and choline and carnitine. Let's see. Preservatives stop microbial growth, but they don't make bacteria die. Ethylene oxide is a sort of lethal gas chamber treatment for surgical tools. Some of my students that work in healthcare have heard of this stuff. I've never actually seen this being used. Endospores and mycobacteria, this is tuberculosis bacteria, are hard to kill. And which does not achieve sterilization? Well, do you guys think about that? Okay. Answer, pasteurization. Yeah. Okay. And that's it. Okay. Thanks, you guys.